This video will show us how to solve two-step equations. We will go through several examples. There are many different types. So our first example has a variable being divided by 7. So our general process every time will be to put a line down the middle and to consider our order of operations backwards. So normally we start with parentheses and go forwards. We're going to start with our adding and subtracting and go backwards. So when we see a plus 20, the first thing we want to do is say, let's subtract 20 on both sides so that this positive 20 and negative 20 will cancel each other out. Then you'll just slide over your d over 7 to put it closer, and you'll do your 24 minus 20, giving you 4. So you've undone your adding or subtracting, and now you'll look and see, are you multiplying or are you dividing? And you'll see d is being divided by 7. So the opposite of division would be multiplication. So you'll multiply both sides by 7. Because you have that 7 on the top and the 7 on the bottom, it will cancel out. And on the left-hand side, you're just left with your d. On the right-hand side, you would do 4 times 7 and get 28. To check your answer, you put it back into the original problem. So for our check, we would replace our d with 28, divide it by 7, and add 20. So then you're doing PEMDAS forwards, and you would have 28 divided by 7 is 4, plus 20. And you're checking, does that equal 24? Well, it certainly does, so you know this checks out. That's one type of problem where you are dividing. Another type of problem we could see would be a distributive property problem. Now this is a large number, so you are going to want to divide by it. You may want to grab your calculator. This implies multiplying here, so you would say that you could divide both sides by 29, and you will save yourself having to multiply that distributive property through. So when you divide both sides by 29, you'll see this will cancel out, giving you 9 minus n minus 987, and 58 divided by 29 is 2. So now you are back to a one-step equation, and that one-step equation you will finish off by doing the opposite of your subtracting. You'll add 987 to both sides. And this will cancel out on the left-hand side, and you have your n equals 989. To plug this in, you can go in and you can say, well, 29 times 989 minus 987. Well, you would follow your PEMDAS, which says do what's in parentheses first. This would give us 2. So you'll have 29 times 2, which is indeed 58. So you'll say, yep, that checked out. Another problem we could see is when things are reversed a little bit. So some people are able to still work with this right as it is. They put their line down the middle and they see that the opposite of subtracting 4 would be adding 4 to both sides. When you do that, you can cancel this out and you're left with 2g equals 10. Then you can divide both sides by 2 and you'll have your g equals 5. Some people get a little stumped by seeing it up here, so I will highlight this in green and suggest a possible first step if you got stumped by that. You could reorganize this and you could use the commutative property, which just means you switch places. So imagine you're commuting to school, you're driving to school, or you're going to work. You would just switch your places. So instead you would have your 2g and your minus 4 switch places. That is the same thing as minus 4 plus 2g equals 6. And this may look more recognizable to you. I'm going to skip the check at this point, but you would do that same thing where you plug it back in. This one is another problem that you might want to reverse the order. So instead of solving it as is, I'll show how to reverse that order. So I'm going to reverse this order twice. First, I will switch these. So I would rewrite this as 2x plus 5. And then I will switch the sides themselves, because sometimes brains think better when they see the variables on the left. So you'll have 2x plus 5 equals 21. Now this should look pretty recognizable. We'll put that PEMDAS back at the top, reminding us that we go and undo it. So we see adding 5. The opposite of adding 5 would be subtracting 5 from both sides. So you'll be left with 2x, and then you subtract, and you get 2x equals 16. And then you see that there's nothing between the 2 and the x. We know that means multiply. So the opposite of multiplying is dividing. They're connected together. So you would divide both sides by 2, and you're left with x equals 8. Again, for the check, you replace your x with the 8. Our last example is another distributive property with smaller numbers. This time I'll show you what you could do if you wanted to actually distribute. So you could just divide both sides by 5 like we did in our first example. You could also say that you recognize the distributive property right away and you want to use it. So you would have 5x plus 20 equals 20. That should look like a familiar two-step equation. So now you would undo your PEMDAS by subtracting 20 from both sides, and you'll be left with 5x equals 0. So that looks a little bit tricky because you have 5x equals 0. You might say, well, I don't know what to do here. So you would then divide both sides by 5, just like you would typically. Don't be phased by that 0, and you'll be left with x equals, and if you grab a calculator, you will see that anything with a 0 on top divided by another number is 0. So you will end up with x equals 0. And that is the end of our examples for two-step equations.